Okay, we've looked at some properties of exponents, including multiplying and raising powers to a power. Today's lesson is division of exponents. Now it's one that appears to be fairly simple, but as you're doing these problems you have to be extra careful that you don't end up with the wrong sign on the exponent, or you don't end up with the exponent on the wrong side of the fraction, top or bottom. So here's your learning target: divide powers with the same base and raise a quotient to a power. You can set up your Cornell notepaper and get it ready to go and fill in the essential question. You might want to hit the pause button now because I'm going to move on. Alright, if you have two numbers as part of a division problem or part of a fraction, and if those two numbers have the same base, you can divide them. But what I'm going to show you first is the long way, and the reason for the rule that I'm about to show you. So if I take 2 to the 6th power, what that really means is 2 times 2 times 2, 6 times. 1, 2, 3, 4, 5, 6. And 2 to the 4th power is 2 times 2, 4 times. 2 times 2 times 2 times 2. Now you could multiply these numbers out and get a big number on the top and a big number on the bottom and then divide, but by writing it out like this, what you can see is that 1 2 on the top will cancel with 1 2 on the bottom. Another 2 cancels with another 2, another 2 cancels with another 2, another with another, and what you're left with is 1 on the bottom, because all the 2's cancel out, and 2 2's on the top, or 2 to the 2nd over 1, or just 2 to the 2nd, which is equal to 4. The same is true if you have two variables, a to the 5th over a to the 3rd. These are like bases, but I'm going to write it out. A times A times A times A times A, 5 A's. And on the bottom, A times A times A. And like the first example, 1A from the top cancels with 1A on the bottom. 1A on the top cancels with another A, and what you're left with is just A to the 2nd power. So in math, recognizing this pattern, mathematicians have come up with a rule. And the rule is, if you have like bases, and you're dividing the like bases, then all you really need to do is subtract the exponents. So if I go back to this example, what I could have done is notice that 2 to the 6th power and 2 to the 4th power have the same base. 6 minus 4 is 2. And in the second one, a to the 5th over a to the 3rd, 5 minus 3 is 2. So here is an example. Problem 1, you can write this down on your paper. You can write out x to the 8th and x to the 3rd like I did the first time, or you can notice that the bases are the same. This just becomes x to the 8 minus 3, or x to the 5th. And that's it. Now sometimes a fraction will contain more than one variable, but that's okay. You still find the like bases, so there's an m to the 2nd power and an m to the 5th power. Now here's where it gets kind of tricky and where some people will mess up. If you're dividing two like bases, you're going to start with the top number and work your way down to the bottom number. So if I'm going to take these two m's and subtract the exponents, it's going to be m to the, start with the top one, 2 minus, then the bottom one, 5. And then I'm going to take the two n's, n to the 4 minus 3. So 2 minus 5 is negative 3, and 4 minus 3 is 1. So I can either write the 1 or leave it. Now you could stop right there, but that's not completely simplified because this has a negative exponent. So I'm going to move it down to the bottom and make it m to the positive 3rd. So my final answer is n over m to the 3rd. Now you may have noticed that I've been working sideways, not the best algebraic form. So let me do the next several and I'll show you how to work down the page. In fact, you could stop right now hit the pause button and try these all by yourself, and then I'll come back and solve them for you. Okay, first example says y to the 5th over y to the 4th. That's equal to y to the 5 minus 4, or just y to the first power. The second example says d to the 3rd power divided by d to the 9th. That's equal to d to the 3 minus 9. 3 minus 9 is negative 6. And that means you're going to move it down to the bottom and make it 1 over d to the 6th power. Now if you'll notice, I'm including some work in solving these problems. Your paper should look just like my paper. So don't skip steps. Don't just write the answer. Don't just give me an answer sheet, because that won't get you anything. Okay, example 1, part C, k to the 6th power over k. This k is implied to have a 1 right there, so that's k to the 6 minus 1. And j to the 2nd over j to the 5th is j to the 2 minus 5. 6 minus 1 is 5. 2 minus 5 is negative 3. The last step is to take this negative exponent and move that down. So your final answer is k to the 5th over j to the 3rd. The problems really don't take a whole lot of time or effort. So to add these extra steps isn't a whole lot of extra time or effort, but what it does do for you is guarantee that you're going to get them right instead of trying to figure it all out in your head and making a small mistake and getting it wrong. Okay, part D says a to the negative 3rd, b to the 7th divided by a 5b2. Again, you have to be careful with these, and you subtract the exponents by working down. So I'm going to write a to the negative 3 minus 5 and b to the 7 minus 2. This is the part that gets people messed up. Negative 3 minus 5 is actually negative a to the negative 8th. And 7 minus 2 is b to the 5th. Take the negative exponent, move it down, and make it positive, and that's your answer. Okay, this last one is a tricky one. So I'm going to actually rewrite it. E is x4, y negative 1, z8. x4, y negative 1, z8 over x4, y negative 5, z. Okay, this is tricky because it involves a couple of negatives that, if you don't take the time to write it out, could get you in trouble. So here we go. X to the 4 over x to the 4, that just means x to the 4 minus 4. It's this middle part, the y's. I'm going to go slow. Y, the first number is negative 1, minus the second number is negative 5. I'm subtracting, so it's going to be minus negative 5. The last part is z to the 8 minus, and there's a 1 implied to be on this exponent, so it's 8 minus 1. 4 minus 4 is 0, so the first one is x to the 0. Y to the negative 1 minus negative 5. Well, the negative here makes this plus, so it's really y to the negative 1 plus 5, which gives you y to the positive 4th. And the last part is z to the 8 minus 1 is 7. Now if you stopped right there, again, you wouldn't be completely simplified because x to the 0 really equals 1. So your answer is just y to the 4th, z to the 7th. And that's it. Okay, now if I have a fraction, or what's known as a quotient, any division problem is a quotient, and I want to raise it to a power, just like we did when we first learned about raising powers to powers, you can rewrite this as 3/5 times 3/5 times 3/5. 3/5 to the 3rd means 3/5 multiplied by itself 3 times. You could also rewrite it again as 3 times 3 times 3 over 5 times 5 times 5. And that equals 3 to the third over 5 to the third. And that equals 9 times 3 is 27 over 125. But in math, we always take something that has a pattern and try to come up with a rule for it. And that's what's happened, is a rule exists that says if you take a quotient like a over b and raise it to a power, really all you're going to do is give the exponent to each part on the top and each part on the bottom, which is what this says. So if I had taken that first example, 3/5 to the third power, all I really needed to do was give the 3 to the 3 on the top and give the 3 to the 5 on the bottom to make it 3 to the third over 5 to the third. And that equals 27 over 125. Now I'm skipping problem 2 and going on to problem 3 on purpose, so if you notice that my numbers are off, it's done on purpose. Problem 3 involves raising a quotient to a power. So all I'm going to do is give the exponent of the 3. It's like the distributive property, but it's not, just like you did when you were doing the multiplication property. I'm going to give it to the 4 here and to the 3 here. Take the time to write it out. X to the 4th raised to the 3rd over 3 to the 3rd. X to the 4th power raised to the 3rd power is x to the 12th power. And 3 to the 3rd power means 3 times 3 times 3, which is 27. And that's your answer. In part B, if I give the exponent of -3 to each part inside, write it out. M to the -3rd over n to the -3rd. Now because you have negative exponents, you can move things around to make them positive. So I move the n up and the m down. That makes my answer n on the top to the positive third, m on the bottom to the positive third. And that's it. And the last one involves a whole bunch of different properties. But the exponent on the outside is raising a quotient or a fraction. So I'm going to give this exponent of -4 to each part inside. Every part inside on the top and every part inside on the bottom. Write it out. 3 raised to the -4th power, x squared raised to the -4th power, over 5 to the -4th power, and y to the 4th to the -4th power. Now because you have negative exponents on every part of this problem, you could start by moving everything. The 3 to the -4th goes down, and the x squared to the -4th goes down. So it ends up on the bottom of the fraction. Then you could do the same thing on the bottom. 5 to the -4th can go up to the top and become 5 to the +4th. Y to the 4th to the -4th can go up to the top and become y to the 4th to the +4th. So all I have to do now is simplify. Y to the 4th raised to the 4th is y to the 16th. X to the 2nd raised to the 4th is x to the 8th. 3 to the 4th power is 81. And 5 to the 4th power is 625. And that's my answer. Now there's a shortcut to that, but I'm going to let you try this the long way first, and then I'll show you the shortcut. Okay, the last problem involves scientific notation, which is why I saved it for last. And what you have are two scientific notation numbers being divided. Really, I could rewrite this though, 1.21 times 10 to the 7th over 4.81 times 10 to the 5th. It still means multiplication. This multiplication symbol is just used in scientific notation. And the reason for doing that is to notice these two have like bases. They're both powers of 10. So I'm going to just notice the powers of 10 have the same base and subtract the exponents to make it 10 to the 7 minus 5, which is 10 to the second. Then I'm going to take the first part of the problem, the first part of the scientific notation numbers, and I'm going to divide 1.21 divided by 4.81. And if I pull out my calculator and divide 1.21 divided by 4.81, I get 0.25155 and then more digits. But that's all I really need for this problem. Is my answer in scientific notation? No. I've got to take this number and move the decimal point over 1 and get 2.5. Now if I just need the 3 digits and I look to the right and see that it's a 5, I'm going to round this 1 up to a 2. And just this part alone is 2.52 times 10 to the negative 1 because it's a small number and I've moved the decimal place 1 time. Times 10 to the second. These two powers of 10, like bases, I'm multiplying, so I add the exponents. My final answer is 2.52 times 10 to the first power. And that's it. 3 problems, 3 examples. Take the time now to go back through your notes, look it over, make sure that everything is clear. If you need to re-watch the video to make it clearer, that's great. Write out questions, summarize your notes, and when you come to class tomorrow, this will be your assignment.